This is Note-Taking Guide 8.9 for Mathematical Decision Making for Life. Today we're going to talk about fairness criteria. So we're going to talk about like voting and how to determine whether or not it was a fair election. So for an election to be considered fair, there are 4 criteria that have to be satisfied. Each of the criteria can be satisfied, violated, or not applicable. So let's look at each criteria by itself and kind of do an example of each one. So criteria 1 here says, if a candidate receives a majority of the first place votes, then the candidate should be the winner. So it says here, the 11 members of the Board of Trustees of a college must hire a new college president. The 4 finalists for the job, E, F, G, and H, are ranked by the 11 board members. The winner is to be decided by a board counting method, 4 points for first choice, 3 points for second choice, and etc. Which means, let's just finish that before we even go on. That means it would be 2 points for third choice, and then we go to 1 point for fourth choice. After that, it doesn't matter because we'd be at 0. So we're going to just do first, second, third, and fourth choice on that Borda method there so that we get to 0. So here we go. This criteria only applies if a candidate receives a majority of the first place votes. Is there a candidate with the majority of the first place votes? So is there a candidate who has the majority of the first place votes? Well, let's look and see. 6 people voted as their first choice for E. 3 people voted as their first choice for G, and 2 for F. So we do have a candidate who won the first place votes. That would be candidate, I meant in my head E, and for some reason I wrote G. So, but we're going to do candidate E is with 6 votes, the first place winner. Okay, now we're going to calculate the Borda method to see whether or not he is also the winner by the Borda method. So let's just take a look at this and see. We're looking for E here, candidate E. So he had 6 first place votes. So 6 first place votes. First place votes are worth 4 points. And then let's go find our other E's on our chart here. Let's see, we have some 4th place votes here and some 4th place votes here. So we're going to go 3 times the 4th place vote, which is 1 point, plus 2 times the 4th place vote, which is 1 point again. And I think that uses all of our E's on our chart. So we had 6 first place votes and really 5 4th place votes. Okay, so let's go and do the next one, and we can just figure that out. Well, let's just figure that out now. So 6 times 4 is 24. This would be 3, so 27, 28, 29. So we get 29 for the value of E using the Borda method. Okay, let's look at F. So here on F, we have 2 first place, so 2 that are worth 4 points each. We have 6 that are second place. Second place is worth 3 points each. We have 3 that are worth the third place vote. Third place is worth 2 points each. And then that would be our total on our F's. So we're just going to punch that into our calculator and figure that out. 2 times 4 would be 8. 3 times 6 would be 18. And then 3 times 2 would be 6. So 8 plus 18 plus 6. When I added that on my calculator, I got 32 for my total there. Okay, now we're going to do our G's. We have 3 first place votes for G, so 3 times 4. We have 2 second place votes, which are worth 3 points each. We have 6 third place votes, which are worth 2 points each. And that's it. So then we're just going to do the math on that on our calculators. When I did that, I got, let's see, this is 12 and 12, so 24. 24 plus 6. I think I got, oh, yeah, 30 is what I got here, it looks like. Okay, and then we're doing H. So the only letter left, H, has some second choice votes. 3 at second choice is worth 3 points each. And then we have some third choice votes. We have 2 of them. Third choice is worth 2 points each. And then we have we have 6 fourth choices, which are worth 1 point each. So then we just do that. That's 9 plus 4 plus 6. So 9 plus 4 plus 6 is 19. Okay, so let's look for the one that got the highest amount. The highest votes on the board account is 32 there for points on F, which means first when we figured it out by just looking at who had the most first place votes, E won. But by the board account, F actually wins. So did we satisfy criteria 1 here? We did not satisfy it, was actually violated. That's the example of criteria 1. So who won by board account? That was F. So because the 2 winners weren't the same by the 2 different counts, we violated that rule or that criteria. Okay, here's our second rule. Our second rule says if a candidate is favored over every other candidate in pairwise races, that candidate should be declared the winner. The winner of this election is to be determined by the plurality vote. If you remember, plurality just means the one that has the most first place votes. So criteria 2 only applies if a candidate is favored over every other candidate in the pairwise races. Is this the case here? So let's look and see. First of all, let's see who would win if we just looked at first place votes. So if we're looking at first place votes, A has 5, B has 4, and C has 2. So if we're looking at the plurality method, we know that contestant A won, or candidate A won. But now if we go and we compare, if A challenges B, and we're looking at first place votes here, so A has 5 and B has 4, then A is going to win because they have more votes. Okay, now let's go look at A and C. So A has 5, C has 4, so A wins again here. And then here, B and C doesn't actually use A in it to compare, but if we did B and C, we'd have 4 and 3, which means B would win here this time. But we didn't use A in that comparison. So to calculate the winner favored over the others in the pairwise, I'm going to say that A won that time because he won the 2 where he was compared against A and against C, which means he was compared against all of the other criterias. And then who wins by plurality? That was A again. So this criteria was satisfied. All right, next problem. Criteria 3. Suppose that candidate X is declared the winner of an election, and then the second election is held. If some voters rank X higher in the second election than in the first election, without changing the order of the other candidates, then X should also win the second election. The winner of the election is to be determined by the sequential runoff. So sequential runoff is where we compare them and then we eliminate the least likely to win. So let's just look at our first place choices here for A. First place choices for A would be 42. First place choices for B would be 28 plus 16. We have to add those together. So we get 44. And then for C, we're at 34. So the lowest one gets eliminated. So C gets eliminated. Okay, we're going to eliminate C, which means over here on the first place votes, C's eliminated, and that means I have to use the second place votes for C instead. Okay, so now we're going to compare A and B, and A now has, let's see, 34 plus 42, because we're using the first place votes here and then these ones that got replaced. So 42 and 34 for a total of 76. And then B still has 28 plus 16, which is 44. So A clearly is the winner when we eliminate the least likely to win. Okay, so in the second election, 12 of the BAC voters decided that they like A better than B. So they become ACB voters. A new table shown here tells us how that happens. Is A still the likely winner? Well, let's do again from first choices, A, B, and C. A has 54 here. B has 28 and 4, which is 32. And C has 34. So this time we eliminate B because it's the lowest one. And now we're going to compare A with C. So we eliminated the first choices of B, which means we have to use the C's here. And we have to use the A's here in the second choices. So on our A's now we have 54 and 4, which adds to 58. And on the second one for C, we have 34 and 28, which adds to 62. So this time the winner is C. So the winner of the first election is A. The winner of the second election is C. Did we satisfy criteria 3? We did not. It was violated because the winner was not the same. Okay, one more criteria here to go over, and then one more last thing after that. So criteria number 4 says, suppose that candidate X is declared the winner of an election and then a second election is held. If voters do not change their preferences but one or more of the losing candidates drops out, then X should also win the second election. The winner is chosen by sequential runoff, which means we run the winners and then we get rid of those, we eliminate sequential runoff is when I just need to make sure. All of a sudden I went blank on this. Sequential runoff is just like up here on that we just did, where we run them all together and we drop off the person who got the least amount of votes. So we're going to start with our A's, our B's, and our C's and run those first place votes and see what happens. So first place winners here, A will be 13, B will be 11, and C is a total of 9 and 5, which is 14. So the person who won by first place votes in the first election is C. The loser is B. So we're going to get rid of B in our first place and use the second choice for those B's instead. So we have to do those. Okay, so now we're running A and C against each other because we got rid of B. So A has 13 and 11 to be 24. And C, because C didn't change, we still have 14, which means the winner is A. Okay. To check criteria 4, test what happens if one of the losing candidate drops out. That's what we just did there. Candidate B lost the election and drops out of the race. If a second election occurred, the winner should stay the same. So now we're going to check the same thing and see if we get A as the winner again. So we're going to go A, B, and C again on this second election and see what happens. So A has 13, B has 11, and C has 14. So B's dropping out again. Okay. And then we're going to do, so B dropped out, and then we're here again. So now we're doing A and C together just like we did before. So A has 13 and 11 to get 24. C has 14, which means A won again. It actually looks like the data didn't change in that second table that they gave us. The winner of the first election is A. The winner of the second election is A. So this was satisfied. Okay. One last section on this note-taking guide today. It says another possible method is the approval voting. Voters are asked whether or not they approve of each candidate. They can approve of as many or as few as they like. The choice with the most approval rates wins. Oh, I'm showing you the page that has the answers already, aren't I? Let's show you the blank one. Okay, approval voting example. Candidates A, B, and C are running for governor. 32% want A, but also approve of B. 32 want B, but also approve of A. 1% wants A and approve of neither B or C, and 35 want C and approve of neither B or C. So by plurality, we would just be counting the people or the percentage of votes. So here, when we do plurality, that would be their first choice. So here, 32% want A. Here, 32% want B. Here, 1% want A. And here, 35% want C. So the total would be 33, 32, and 35, which means C would be the winner by plurality. Approval, though, we're going to add everybody that gets approved of. So on approval, who wants A? 32% want A, but they also approve of B, which means 32% of people approve of B. 32% want B and also approve of A, which means they both get numbers. 1% want A and don't approve of B or C. And then 35% want C and then don't approve of B or C. So up here we get 65, here we get 64, and here we get 35. So A won in the approval method because more people approved of A, where more people directly wanted C to win. So that's how the approval method works. All right, you guys, that was a long note-taking guide. Thanks for watching. Good luck with your homework.